Hidden by clouds of dust and interference from our own atmosphere, black holes have traditionally been very difficult to see from Earth. But recently, 300 scientists working together across 20 countries as part of the Event Horizon Telescope began to probe some prime suspects in our cosmic neighborhood.
You need a telescope the size of the Earth in order to see a black hole. And the technique is actually well known. It's called very long baseline interferometry.
So it's not a single telescope, it's actually a network of radio antennas. We use telescopes on top of mountains, very tall mountains, to get past the Earth's atmosphere, and we recorded a wavelength of about 1 millimeter. So this is pretty much the highest radio wavelengths that reliably can be observed from the surface of the Earth.
The signals arrive onto the telescopes, we time tag them, we record them onto hard disks, and then we ship these hard disks to correlation centers, which are supercomputers that then combine the data together, realign all the signals between the telescopes, and create this virtual telescope the size of the Earth.
You might remember seeing this image back in 2019. This was Event Horizon Telescope's first big release, an intergalactic snapshot of a massive black hole in the M87 galaxy. 2 years later, they released this, an even more detailed image of M87 that revealed a spiraling magnetic field swirling around the black hole.
It confirmed in vivid color that the black hole is forcing matter to move around it at light speeds. We're looking at the orbits of gas around the black hole.
Though the images from M87 dazzled the world and proved the capabilities of the Event Horizon Telescope, the scientists had their sights set on a suspected black hole much closer to home, Sag A star in the constellation of Sagittarius.
When I entered the field of radio astronomy as a student, I was told about this enigma, this mysterious radio source Sag A star at the heart of our galaxy. It's very exciting here today to show you this best ever image of that enigma Sag A star.
The similarities between these images is fantastic. And that's because we think that black holes are described by just a few parameters. These are punctures in space-time so severe that it doesn't really matter how you light up the black hole, it's going to appear the same, almost from any direction too.
Even though it's significantly smaller in size than M87, Sag A star displays the same telltale warping of space-time predicted by Einstein's theory of general relativity offered over a century ago.
This was a confirmation, and it was important confirmation because when you see one black hole, even though the M87 result was extremely clear, seeing a second ring really confirms it. You know, 1 is promising, 2 is now a certainty.
Black holes are destructive forces because they are sort of the graveyards of stars, but they may also have a creative potential because they regulate star formation. As matter falls in, they become very energetic, blow out gas. And, their outflows may actually create turbulence and distribute matter around in the galaxy. And so maybe some of the elements of life that are inside us are here today because our black hole was more active in the past and was acting like a big mixer and distributing elements around the galaxy.
In coming years, the EHT aims to link together even more telescopes around the world to increase the size of their global array as they continue to probe the deep and dark unknowns about black holes.
A lot of the motivation we have with the EHT is that we're basically opening a new laboratory to studying these mysterious objects.
As far as open questions, we'd really, I think, like to pin down some of the properties of these black holes better. Getting the spin of a black hole would be a major achievement.
The next big questions for Sagittarius A star would be, can we make movies? Can we resolve dynamics at the event horizon?
The modern technology lets us see black holes and it makes you feel almost omnipotent. But then the same image tells you where your limits are because you never can overcome the event horizon. It tells you until here and no further.
We know that we don't understand what happens inside of a black hole. That's why I think people are interested in black holes. They represent the deepest mysteries and we're making inroads on them. It also gives me hope for the future. There's so many problems that face us as humans on the planet that seem intractable. And you see the Event Horizon Telescope succeed and you have hope that we'll be able to tackle these global questions together.